Let's take a look at the next one. Now, it may be that we don't, we may use this one for that one. It just depends on what we find that seems to be the most interesting or most surprising. Okay, so here is our second random packet of 6 cards. Okay, so quickly, as an AMP, what do we see? Well, we see a non-matching color pair here, a non-matching color pair there, the Queen and the 3, whereas the 2 and the 8 match in color. So that's kind of interesting. So if we were to view this as an AMP and go through and mix it, we could eventually put out the cards in pairs, where the pairs would be this set of 2 here, these 2, and then finally those 2. And then you would be able to say, boy, we've mixed these in such a way that one of these pairs consists of 2 even value cards that are, I think, the same color. I think I can see that in my mind's eye. Yeah, one of these pairs is like a 6 and an 8 or 2 and a 4 or something, and they're both red. And the other pairs are of opposite color for sure. I can just see that. Okay, so that's the kind of thing we could do at the end if we choose to view it as an AMP, which you don't have to. So let's go ahead and look at it as a mirrored structure. Okay, so this is where we look at the outer ones and say, okay, is there anything interesting about those 2 cards as a pair? Well, they're of opposite color. They're opposite parity as well, right? Jack is an 11. Coming in one. Oh, that's very nice. Look, we have a 3 of diamonds and a 2 of diamonds. That might be worth revealing. And then if you come all the way in, we just have 2 cards of the opposite color. Okay, so if we chose to view this as a mirrored structure, what we could do is say the pairs consist of cards of the opposite color except for one of the pairs. And that one pair actually is a pair of diamonds. Wow, isn't that interesting? Okay, so why don't we, okay, so we looked at it as mirrored. Okay, why don't we take a look at it as a 2-cycle? Woo! Okay, look at this. The Jack and the 3 are related relative to the 2-cycle structure of the packet. Those 2 are both the first cards in their respective cycles. And look, they are of the same color and suit. Move one over. The 3 and the 2, same color and suit. And then we get another pair, Queen of diamonds and an 8 of hearts, the same color, which is nice, but not quite the same suit, but that's okay. So what we could do is, if we viewed this as a 2-cycle structure, we get the cards matching in color and in suits, except for the silly Queen and 8 here. Okay, and so if you can kind of squirrel away that information and say, boy, at the very end, when you get to the end, you can say, boy, these pairs, I don't know, they all feel like they're the same color within each pair. I wonder how many of them are of the same suit. Boy, how likely is that? And then you could say, well, I don't think they're all of the same suit. I think one of these is like a heart and a diamond or something. But the other 2 pairs actually match in suit. Wow, how in the world could I possibly sense that after randomizing the cards, using the shuffles, and making the choices that you, the spectator, made? That's amazing. Okay, so why don't we go ahead and do that? So we're going to view this as a 2-cycle structure. And so really all you have to remember is that 2 of the pairs will match in suit, actually. Great. Those 2 and those 2. You don't have to remember what suits they are unless you want to. I mean, the more information you can kind of recall, the more powerful the reveal would be. But just to say that we have 2 pairs of the same suit, that's pretty powerful. And then you could point out, well, the other pair is not bad. They actually match in color, but not suit. And I think they're red, maybe. I'm not sure. Okay, so let's go ahead and write that down. That sounds like a great way to go. So this could be pile 3. So we could say 2. I'm just writing this down for us because we'll, for us to remember all 3 of these at once, it's going to be kind of confusing. So 2 pairs where it's the same suit within each pair. And then we have 1 more pair plus 1 pair. I'm not sure why I put that in parentheses there. Sorry about that. 1 pair, same color. Oh, we could even say 1 red pair. Yeah, well, let's do that. I don't think that would be too hard to remember. Okay, 1 pair, that's red. Okay, so 2 pairs of the same suit and 1 pair, and they're both red, but they're actually not of the same suit. That's kind of interesting. Okay, so let's put this away. This will be our pile 3 in just a few minutes. So let's take a look at our last one, which we set up as a 2-cycle structure relative to these properties here. So there's 2 pairs of the same suit. That's really nice. And then there's a pair not of the same suit, but of the same color. Now, if you want to squirrel away that it's a red pair, that might be fun to reveal. I mean, the more information you can remember, the better, really. But if you can just remember, okay, 2 of these pairs have the same suit, and then the remaining pair, it's not the same suit, but it's actually still the same color. And I think I'm seeing red. I think they're both red. Now, something I should point out before we finish with this one is you have to realize that we are, for the sake of this video, doing 3 different routines, kind of all at once. So it would be hard to remember all of these, but you have to realize that you would just do 1 of these. Like this one here. This would be the only one, and this is the only information down here you're needing to hold on to. Okay, so I want people to realize that, not become overwhelmed and think, I can't remember all that. So you're just needing to remember that for this particular packet that we've set up. In some ways, we didn't set it up. That I shouldn't have said that. It was randomly dealt out, but we noted some structure of interest, and that's actually pretty decent structure there, to have 2 pairs of the same suit by a random process, and then have the remaining pair be of the same color at least. That's pretty unlikely, you would think, right? Okay, so this is a 2-cycle. Well, we've mentioned that you can do the Charlier with a 2-cycle, a random cut, but what I decided to do here is just jump right into converting it to a mirrored structure. So if you come over here to line 14, the Klondike shuffle, it's a very, very useful shuffle. It'll take you from a 2-cycle to a mirrored, and from a mirrored to an AMP. Isn't that nice? So right now, being a 2-cycle, if I perform a Klondike, and we perform Klondike shuffles in the first video of this series, but we haven't yet here. So this is where you take the top and bottom card off as 1 and set them down. Top and bottom off as 1, set those down, and then there's only 2 left. So that's called the Klondike shuffle. And what it's guaranteed to do to a 2-cycle is it will convert it to a mirrored structure. And I want to point that out. Now, you do need an even number of cards for everything that we're kind of doing in this series right now. But if you have an even number of cards and you have it set up, or it is set up as a 2-cycle, a Klondike shuffle will always convert it to a mirrored structure. Whether it's 4 cards, 6, 32, 112, as long as it's even, it's going to work. So it's a mirrored structure now. Well, now we have the stay stack principle. Okay. Oh, and I do want to point out something that I've kind of glossed over. I'm calling this the LR3. And partly because I think it's a kind of a clear name for it. You're doing a left-right, and now we're going to do 3 piles, right? But what it relates to on the table is the RC shuffle. Let me point that out because I have mentioned that. So if you look at line 10, something called the RC shuffle. R is for row, C is for column. Or you can just think of it as a factoring of the packet size. Like here, 2 times 3 is 6, or 3 times 2 is 6, that kind of thing. But when it's mirrored, that kind of shuffle leaves mirrored structures alone. So this is the stay stack principle really in force right here. Okay, so the LR3 just means do it into 3 piles like we've done earlier with random stacking from left to right or right to left. Maybe if they ask for right to left, that's fine. And then we can just do an ordinary LR. And we can do as many of these as well as the spectator calls for. So that won't hurt the fact that it's mirrored. An even or odd up jog. I don't know if we've used that. We haven't used that to preserve a mirrored structure in this current video. We did last time. So an even or odd up jog. So this is where you push forward or jog up either the even position cards or the odd position cards, and then strip them out. So right now I have like the second card is being jogged up, 4th and 6th. Okay, so it's like I'm doing what's called an even up jog, and then you just randomly stack these. Well, that action actually preserves mirrored structures as well. Okay, and now we're going to do one that we haven't shown you. It's a really cool one, powerful one. It's called an alternate Klondike. That's what the AK stands for. AK down here, alternate Klondike. And so as you can see, what is it? The longest chain, isn't it? It will take you from a mirror to an AMP to a 2-cycle to a mirrored. It will do a complete cycle. So you can go all the way around. Just this original little chart here that we had, the simplified version, you can just go round and round kind of thing. Okay. Now there are restrictions for some of the legs of that journey, if you notice. So going from an AMP to a 2-cycle, you do need a multiple of 4 for the number of cards for it to work. And the same thing, if you go to a 2-cycle structure to a mirrored structure, you'll need like a packet of 4 or 8 or 12. 12 is what we used last time. 16, 20, 24, that kind of thing. But right now, we're looking at a mirrored structure, and there's no restriction. So going from mirror to AMP will work using this alternate Klondike. Well, as the name suggests, it involves the Klondike shuffle, and you alternately set the cards down into a left pile and then a right. Okay, so here we just start just like a regular Klondike. So you go left, then top and bottom, go to the right, only have 2 left. That one would go on the left. So you just left, right, left, right, until you run out of cards. And now you can stack these in either order. Isn't that wonderful? Okay, and once you've done that, you'll have what's called an AMP, which we've worked with already, of course. And then there is a shuffle that will leave the AMP structure alone. It doesn't actually have a name that I'm aware of, so I gave it a name. I call it a Bessie 2-2. Okay, there's also a Bessie 1-1 that we'll look at if we haven't already. Maybe we can talk about it in the next video. But it's similar. A Bessie 2-2, it will preserve an AMP structure. So a Bessie 2-2 is done as follows. You hold the cards just like you're doing a Klondike, but now you take a card from the top twice. You go 1, 2, and then you take a card from the bottom twice. So I'm taking from the bottom now. 1, 2, and then you take from the top again. 1, 2, 1, 2, and then you just repeat those actions until all of the cards have been moved from one hand to the other. And that kind of shuffle, and if you give it a little bit of thought, you'll realize that should leave AMP structures alone. Remember, the AMP structure at the very bottom is like you have a 1-1, 2-2, 3-3. Well, with this Bessie 2-2, it's like you're taking the top 2 off, dropping them into your hand, other hand, and then you take the bottom 2 off, I guess, which here would be the 3-3, and then the next top 2 would be 2-2. So you'd be leaving them in blocks because you're taking 2 at a time from the top or bottom. It will leave AMP structures alone. It won't hurt them. Now, it does rearrange the pairs, the 1-1, 2-2, 3-3, but that doesn't change the fact that it has that characteristic that every pair taken from the top is related in the special way that you've set up at the beginning. And then finally, we can change this to a DMP by doing something I call POP. push off pairs. Now if we go to my chart, my table there, I give it a more general name. It includes the push off pairs as a special case. It's down here, POE. That stands for push off any even number of cards. So you can push off 2 or 4, 6, okay? So any even number. So we're going to go ahead and just push off cards in pairs. But that kind of mixing of the cards will preserve mirrored structures as well as AMP structures. Isn't that great? Okay, so push off pairs, this is where you don't necessarily rearrange the cards in the pair. It won't hurt if you do, actually. So you push off a pair, and push off the next 2, and then push off the final 2. And now this is officially a DMP. These are the pairings that we wanted to preserve at the very beginning. And then if you remember, what we noted is that 2 of the pairs have exactly the same suit. And then there's one final pair. The cards in that pair don't have the same suit, but they are of the same color, and that color is red. Okay, so however you'd like to reveal the fact that you know that. So 2 of these match and having the same suit. Oh, there you go, both clubs. And then one won't have the same suit, but they'll match in color. And that would be this one right here, right? So not the same suit, but they're both red. And here we go, those match in suit as well. They're both diamonds.